Hey everyone, in this video we are going to be talking about balancing chemical equations. So you can already see here that I have the decomposition of water written down, but I want to talk about the parts of a chemical reaction again just as a review. So if you remember that we start out with our reactants, we can think of those as our ingredients, and then we form our products. It's kind of like if we were baking. You start with your ingredients, you put them all together, and then you form your final product. Remember that the arrow means yields / forms. And then something that we also need to talk about is what the G and the L in parentheses stands for. So that just tells you the state of whatever your element or your compound is. So for example, L means that it is a liquid. S means that it is a solid. G means that it is a gas. And then AQ is aqueous, and aqueous just means that it is dissolved in water. Okay? And then the other thing that we need to talk about is these numbers in front of our elements and compounds. So what I just circled or put a square around in pink, those are going to be coefficients. And so the coefficients are whole numbers that represent the number of reactant and product particles needed to have a balanced chemical reaction. Okay, so coefficients are whole numbers that represent the number of reactant and product particles needed to have a balanced chemical reaction. So, whenever we have our chemical reaction, we can only use what we start with. Meaning that however much hydrogen I have, if I look here, however many hydrogens that I start with, that's how many hydrogens I have to end up with in the product. Okay? So I can't have more and I can't have less on either side. So let's do some examples of balancing. So let's look at this H2O, H2 plus O2. Now, first off, as a review, let's look back at the type of reaction. So this one, we have one thing being broken down into two, so it is going to be a decomposition, okay? Now, if I look at this right now, we first need to go through and we need to figure out the elements that we have in our reaction. So we have an H and we have an O. We're going to write those underneath our arrow. Then we're going to go through and tell how many of each we have on both sides of the arrow. So for the reactants, we have 2 hydrogens, 1 oxygen. For the product, 2 hydrogens and 2 oxygens. So my goal with balancing is to make the numbers on either side of my element be the same. So what we're going to end up doing is putting in coefficients. those coefficients are going to allow us to multiply. So for example, if I have 2 oxygens on the product side and 1 on the oxygen side, if I put a 2 over here, okay, I then have to distribute that 2. So for the hydrogen, 2 times 2 equals 4. So I now, instead of 2, I have 4 hydrogens. And then over here, 2 times 1 equals 2 oxygens. So now my oxygens are taken care of, but I've got to figure out what could I put in front of this H2 to try and make it 4. Well, I can put a 2. And whenever I do that, I'm going to have 2 times 2 equals 4. And so now we are balanced. Okay? So that means that my balanced coefficients are 2, 2, and then 1. So if there is not a coefficient in front of an element or a compound, then it's just understood to be a 1. Okay? So let's work through another one. This time we have H2 plus Cl2 is going to give us HCl. Well, first off, let's tell what type of reaction this is. I have 2 things, and they are going into one. So this one is going to be synthesis. Okay? And then we go through and we write our elements underneath the arrow. So we have H and we have Cl. We have 2, 1, and 1. So I want you to try on your own, what could we put in front of the HCl that will allow us to have 2 H's and 2 Cl's? We could put a 2. So whenever we do that, don't forget we have to distribute that. So we would have 2 hydrogens, 2 Cl's, and then we would be balanced. So our balanced coefficients would be 1, 1, and 2. Okay? Now, let's try another one. So I want you to try this one on your own. So Al plus Br2 is going to give us AlBr3. So you try this one on your own. Start with your elements underneath your arrow and then go through and balance this one. So I trust that you have paused and that you have tried this out, but we're going to list Al, Br. We have 1, 2, 1, and 3. Okay? Well, since I have 1 for my ALs, I'm not really going to worry about them. But now, I've got to think about what do 2 and 3 have in common? What is going to be their least common multiple? Well, the first thing that comes to my mind is a 6, that I want to try and get everything to a 6. So what should I multiply 3 by to get to a 6? Well, a 2. So if I put a 2 here, I now have 2 aluminums, and then don't forget, we have to distribute. So 2 times 3 is going to be 6 bromines. If I come over to the other side, 3 times 2 is going to be 6. Those are now balanced, but my aluminum's not. So I need to figure out what can I put in front of the aluminum. Well, a 2. And now we are balanced. Okay? So for this one, our type is going to be synthesis, because we have 2 things coming together, and then our balanced coefficients are going to be 2, 3, 2. Okay? Alright. we got another one. And again, I want you to try this one on your own. So pause the video and try this one on your own. Okay, I trust that you have paused. So let's list out our elements. We have Na, H, and Cl. Reactant side, we have 1, 1, and 1. Over here, we have 2, 1, and 1. So my first thought is, well, let's take care of this hydrogen. If we put a 2 here, we now have 2 hydrogens and then 2 Cls. Well, if we come over to the other side, if we put a 2 here, we then have 2 NAs, 2 Cls. So put a 2 in front of the Na, and then we are balanced. But don't forget that we have to go through and we have to tell the type. So for this one, our type, if I look at this, I have one element by itself and one element by itself on both sides of my reaction. So this one is going to be a single replacement. And then the balanced coefficients are going to be 2, 2, 1, and 2. Okay? We've got a couple more examples and then we will be done. So next one, and again, you try this one on your own. K plus Cl2 gives us KCl. So you pause and you try this one on your own. Okay, I trust that you have paused. And then let's work through our steps. So we list out our elements first, K and Cl. We have 1, we have 2, we have 1, and we have 1. Well, let's try and fix our Cls. So if we put a 2 there, 2 Cl, 2 K, then put a 2, and we are balanced. Okay, so now, don't forget, we have to tell the type. So in this case, our type is going to be synthesis because we have 2 things coming together into one. And then our balanced coefficients are going to be 2, 1, and 2. Okay? Now, this next one is going to be harder. And I want to work through it with you because if we look at this, once I get it written down, we can see that this is going to be a combustion reaction because we have carbon dioxide and water as products. We have a hydrocarbon as a reactant. Anytime that you see a combustion reaction, know that it's going to take you a minute to balance this. The reason why is because you're going to, where you have oxygen here and oxygen here, you have to count those in one lump sum. And what I mean by that is whenever I list these out, C, H, and O, on reactant side we have 2, 6, and 2. Here we have 1, we have 2, but we have 3 oxygens total on the product side. Because of that, it makes it really, really hard to go through and try and balance this. Typically, you don't end up with odd coefficients, but you will for a combustion reaction. Okay, so let's just go through this and see what we can have happen. And don't be afraid of erasing coefficients. So if I start with a 2 here, okay, I'm going to have 2 carbon, but now I have 4 oxygen. Okay, well, if I look at these hydrogens, if I put a 3 here, that's going to give me 6, okay? But if I pop back to this oxygen for a minute, 2 times 2 is 4, but I have to include that other oxygen. So I really have 5 oxygens. Okay? Well, if I come over here, there's not anything times 2 that's going to get me to 5. Okay? So then I've got to go through and I've got to think, okay, what could I change then to try and get my oxygens to be the same? Okay, so let's say if we put a 4 here. 4 times 2 would be 8 hydrogen, but now we've got 4 oxygens here, so 4 O's there. Now we have 4 O's there. That's going to be 8 oxygens total. Okay, but if we come over here to this other side, okay, if we go through and we are trying to get our hydrogens even, okay, they are currently not even. And there's not anything that I can multiply that 6 by to try and make it an 8, okay? So, what I'm going to do is I'm going to put a 2 here, okay? 2 times 2 is going to give me 4 carbons, 12 hydrogens, okay? Now, I can come over to this side and I can put a 6 here. 6 times 2 is going to give me 12 hydrogens, and then I'm going to have 6 oxygens here, okay? So 6 and then plus these here, that would get me to 10. But again, okay, if I come through, okay, this carbon is still not balanced. So we're going to have to change that. So I'm going to put a 4 here. So I now have 4 carbons. 4 times 2 is 8, okay? And then plus 6, okay? So 8 plus 6 is going to give us 14 oxygens. And then over here, 7 times 2 would be 14. And like I said, that one is a lot because you have to go through a lot of steps and kind of maneuver your way through. Okay, and then last thing that we need to talk about with these notes is what happens whenever you have polyatomic ions in reactions. Okay, so polyatomic ions that appear on both sides of the reaction/equation can be grouped as a single unit for balancing. Okay, and what we mean by that is, for example, if we had NaOH plus CaBr2, it's going to give us Ca, and hold on, I wrote too big. CaOH2 plus NaBr. Okay, so when I'm going through my element list to write these down, I'm going to start with Na, but then I have OH together here and I have OH together here. Okay, since they are a polyatomic, meaning they are on our PT of ions, they are on the both sides, we can group this together. Then our Ca and then our Br. So we have one Na, we have one total OH, one Ca, two Br. We have one Ca. Remember, this coefficient right here tells us that there are two OHs. Then we have 1 Na, 1 Br. So I'm going to work with the Br first. So if I put a 2 over here, I then have 2 Na, 2 Br. And then if I put a 2 here, 2 Na, and then 2 OH. Okay? And then for this one, for the type, this one, I don't see a single element by itself on either side of the arrow, but I do see two things being replaced, meaning that the Na comes over here with the Br, and then the Ca goes with the OH. So that means that this one is going to be a double replacement. And then the balanced coefficients are 2, 1, 1, and 2. And that is it for these notes.